Hello, I'm Philip Marris. I'm the CEO of Marris Consulting. I've been implementing the theory of constraints, usually combined with Lean, for over 30 years, over 200 times throughout the world in all sorts of industries, designing and making cars, trains, aeroplanes, rockets, hamburgers, and many other things. This is the third video in a series of 4 videos about critical chain project management that are a short extract of the one-day courses that we very regularly run on critical chain project management, right? So in about 4 times 20 minutes you get the equivalent of what is in a one-day or 2-day course. So it's going to be a quick summary of what happens in execution under critical chain. I guess it's one of the more intriguing videos because this is where you actually understand how it all works and therefore how it is possible to get those extraordinary results that critical chain is obtaining all over the world. The doing twice as many projects with the same resources, doubling the productivity, doing your projects twice as fast, basically finishing all your projects on time, or most of them. And so how is that possible? And you'll understand it here. But just one piece of warning, to fully understand this video on execution, you really need to watch the previous one on planning, because we are often referring to that. Okay, so you can watch this one first if you wish, because it's the one that shows you how you get these results. But to implement what we're presenting here, you need to have a look at the planning video just previous to this one. So let's go back to the example we were using on a project. This is the Gantt chart that we developed in the video on planning. It's scheduled using the critical chain way, and we have a certain number of resources: Peter, Simon, Solange, Cecilia, doing various tasks. Okay, we have identified the critical chain. It is in red. Therefore the other resources and the other tasks are in blue, and we've added buffers. This is the project buffer down here, and these are the feeding buffers that ensure that the non-critical stuff doesn't impact the critical chain. Okay, and so how do we ensure the best possible execution, the best possible performance of such a project? Well, it is the critical chain that determines the success or failure of the project. If I gain 3 days along the critical chain, the whole project goes 3 days faster. If I lose 4 days on the critical chain, the whole project gets 4 days later. Okay, so what I need to do is ensure that the execution of these tasks is done as well as possible. To do that in the execution mode, we recommend that you use the relay race principle, and you imagine that there's a baton passed between these different actors as they go from one task to another, that baton representing the project. Okay. More precisely, what we actually do, it's just the way we developed it, and I know our clients love it, is we choose, or rather they choose, a mascot, some usually fairly large, remarkable object, and because of our client's sense of humor, it's often something quite silly, right? We have some examples here. Our record right now of silliness is a pig, which was a toy for a 3-year-old kid, so it was about this tall, a big pink thing, which went oink oink, and that will follow the tasks of the critical chain, right? So this big pink pig went from one office to another all the way through until the project was finished. This remarkable object was there to say, watch out, this person is working on the critical chain, please do not disturb, because they are defining whether that project is going to succeed or not. Okay, so it's a way of visualizing clearly where that critical chain is. Okay, and you can have, of course, several projects in a portfolio, and you will have several mascots going through the company. Another thing we also do, which is exactly aims for the same result, is that we create critical chain rooms, special offices, where people can go to work when they are on the critical chain, right? So when Simon here has to do that task, he will go to that office. In that office, it is protected against interruptions. That's to say, there's no possibilities of ingoing phone calls, and maybe there's somebody guarding the door to make sure that they will not be interrupted, right? And they are allowed. They can therefore work there in the best possible conditions and not be interrupted. And for the more extreme cases that we've seen, they have to leave their mobile phones outside and stuff, so they're really perfectly concentrated. And that works well. The critical chain for a project is only at one particular location at any one time, right? It's not at two places at once. Okay? So it doesn't concern all the resources. It only concerns maybe a few people. To give you an example, we were working recently on a big project for a big part of an aeroplane with 500 engineers working. The project was, of course, overdue, with over budget, and everybody screaming all over the place, and we applied critical chain. When we'd done the modelling and worked out what was going on, in fact, the critical chain was actually being done by a dozen people out of the 500, right? So we had to protect the work of 10 people within 500 to ensure that the project as a whole went properly. And the 490 others, we just had to synchronize their work so that they would be feeding the critical chain appropriately. Now, let's look at how you monitor the project. Excuse me if I go through a few basics, but in the strange world of projects, we need to remind ourselves of some bit of common sense. If that is the status date and that is the project, okay, it's just about to start, right? Everything's yet to be done. A little bit later, we're here, okay, and we do a status update. Where are we? This is where we wanted to be. Let's see what happened. Well, that task, it was planned in the past and it's finished. This task was planned in the past and it's partially finished. Okay, there's still some work left to be done. And finally, this task was planned in the past, but it's not done yet. Okay, so what do we need to do? Well, we now still have to do what we haven't done yet. Excuse me for the basics, but this is not always done in project management. And so the update is this. All the stuff that's done we forget. What still needs to be done is here. And so forth. Okay? Updating that in this way using critical chain software is basically just a press of the button. To do this properly, you ask people, to declare the work they've done. Yes, I finished that, and so forth. You're probably asking them how many hours or days they spent on the different projects, right? What was the time consumed? To do the critical chain monitoring properly, you also need to ask them what is the time left remaining, okay? And that time left remaining is not what is left over from the budget or the time allocated. Let me take an example. Let's say I have a task to do that is 4 days long, okay? Off I go, and I have to do a status update after 3 days, okay? So after 3 days, I will declare I've spent 3 days working on that project, okay? But I will not declare 1 day left of work to do. That, the computer knows, is what was expected. What is really interesting is how much there really is left to do. So I might well say I still have 3 days of work left. Okay, I've done 3, but I've still got 3 to go. That's a 6 in total, right? So I'm going to go over what was expected. And that is perfectly normal, because I remind you that the times that we're putting in the system are normally focused average duration. So in half of the occurrences, I'm going to, and I'm perfectly allowed to, spend more time on that task than was planned. Okay, that's not a problem. We'll see why, or you know why if you've been following the series, because of the project buffer. Okay, so let's see now how this happens on the case we've been following from the beginning. Right, the project started here. After 1 week, we do a status update, and in fact, everybody has done exactly what was expected. Okay, so there's no consumption of any buffers. Everything's fine. Just for you to get used to the graphics, that means that it's finished, it's done, and when it's not, it's because it hasn't been done yet. But watch out, these are weekends here. Okay, so that's fine. End of first week, everything's perfect. End of second week, okay, we're here. Beginning of third week, what's happening? Well, Peter was meant to work on a task that was on a critical chain, and he has got 2 days remaining. Okay, so he has to do those 2 days of work. Okay, and because he was on the critical chain and he's 2 days overdue now, it has consumed 2 days of the project buffer. Okay, so we're monitoring the impact of progress on the critical chain so as to know what's happened to the project buffer. If we look at another part of the project here, we had a whole bunch of tasks that needed to be done that were non-critical. Okay, Solange was meant to do this task here, and she hasn't quite finished. She's still got a day of work to do. Because she hasn't finished that task, Adam, who had to take on the next task, couldn't start, so he's completely overdue. And Cecilia, that was doing something else, is nearly finished, but she's still got 1 day of work to do. Okay, so what hasn't been done yet needs to be done, and so we put that back into the future. Okay, and then we calculate what that means in terms of an impact on the buffer, and we find that it's consumed that much of the buffer here. I remind you, this is the feeding buffer. These are feeding buffers here, while that is the project buffer. Okay, so you do this across the project, and again with critical chain software, that happens just automatically. It calculates all that, and you get this status update where everything's repositioned in time dynamically, and you know how much you're consuming of your various buffers. Okay, so what happens next? Well, next we come to the well-known fever chart, maybe the symbol of critical chain. And what does the fever chart represent? It's very simple. Along this axis here, it is the percentage of progress on the critical chain. So any project will start here and finish here, right? So we measure the progress of the project, and the way of measuring the progress on the project is the percentage on the critical chain, right? On the other axis up here, we're measuring the percentage of consumption of the project buffer, okay, from 0 up to 100, okay, and that's the way it's presented. From one author or one software editor to another, this can be slightly different, the colors and so forth. We like this one, but there are ways of doing it. It's completely empirical, these colors. The idea is basically that if you're in the green zone, you're okay. If you're in the yellow zone, watch out. And if you're in the red zone, beware. Okay. So let's look at the execution of a project. It starts here, obviously. After a week, it gets to here. It's consumed some of the buffer. That's normal. That's what it's there for, but nothing worrying. End of the second week, it's up here. Watch out. You need to keep going a bit faster, please. And so yes, for a whole week you're going at the speed expected, and so you're going horizontally, and so that's the status on week 3. Everything's fine, you're in the green, okay, and then you do the status update at the end of week 4, and you're up here. What has happened? Well, we've absolutely not progressed, and therefore we've consumed entirely buffer. That's all that's happened. We're going up vertically, okay, so there's something, the project is stalled. So management needs to have a look, see what's blocked. Is it a problem with the client? Is it a problem of absent resources or whatever? Find a solution, okay, and put the project back on track so it goes off and, for instance, finishes here. Okay. Now, again, for beginners, this is going to be surprising, but because what does that mean? That means the project was finished early. Okay. This is on time up here in the top right-hand corner. If I finish up here, I just finished the project on time, and yet I finished this one early. It's something that you need to get used to, but in the world of projects where everything is uncertain and there are risks all over the place, until the project is finished, you never know it's really finished, right? And so if you want to finish all your projects on time in an uncertain environment, you better aim to finish all your projects early, okay? And so when systems are properly tuned in critical chain, you should be finishing around here most of the time, right? So that is how you monitor the progress of a single project using critical chain. And the beauty of this system, of the fever chart, is that you're going to use exactly the same chart for managing a whole portfolio of projects. It's the same, except each one of these dots here now is a different project. Okay? And you can put them all on the same page, even if they're very different objects, because we're talking in percentages here. So you can put a big project and a small project on the same sheet of paper, okay? And this happens a lot. I mean, a lot of organizations have big and small projects going through simultaneously using the same resources, right? And you want to be able to arbitrate on priorities and put them next to each other to decide which one, even if there's a big one and a little one. Take an example. I'm an engineering department that designs products, big complex products. Those projects take a year to do. Okay, so it will take a year for a new product to go through here and get finished, right? But it's the same team that is solicited to answer or to contribute to call for tenders, right? And the call for tender, you have to deal with it in 1 month. Okay, so you might well, that's certainly we recommend it, run projects that are replies to call for tenders, and in that case, that project will go through the fever chart in 1 month, not 1 year. Okay, that's the beauty of putting it in percentages. In the same way, on the other axis, it's a percentage of the buffer, and therefore you can put projects that haven't got much variability and therefore don't have huge buffers. And you can put next to them a project which, for various reasons, has a lot of uncertainties and has a very big buffer. But it's all in percentages, so you can put everything on the same page, or at least you need to put everything that's going through the same resources and the same part of the portfolio on the same page. And that's the system. And the beauty of it is that it will allow you to dynamically arbitrate the priorities of all your resources for them, so that they can decide on what project to work on. Okay, let's take 2 simple examples. We've got project 1 that's here and project 3 that's there. Okay, they both need to be worked on by the same person, Susan. Okay, she has to do these 2 tasks. She arrives on Monday morning, and she has these 2 tasks to do. Which one of the 2 should she work on? Okay, well, the way of defining the priority, okay, is in fact to find the project which has the worst ratio of project buffer consumption divided by progress on the critical chain. Okay, that's the mathematical formula. In practice, in visual, it's quite simple. It means the priorities are defined in this way. Okay, you'll find the priorities by the ones further up on that ratio. Okay, these are priorities compared to those. So Susan looks at the fever chart. She has either to work on that one or that one. Well, it's easy. I work on P1. That is the priority, right? And that's remarkable because I think most companies that are not using things like critical chain will probably get Susan to work on that one. Why? Because among other things, all their projects are late. So that project is actually late. It's nearly finished, so they want it out the door. Okay? In this environment, everything is on time, right? So that's, if it carries on like that, it's just going to finish a little early. It's not a big problem. P3 is going to finish a little early. Okay? So it's perfectly reasonable for Susan to come and work here, because that is a really worrying one. That's a project that had a problem at birth. Maybe there's a problem with a client that can't decide what he wants, or maybe the proof of concept is not going well. Anyway, there's something going on here which is completely unusual. So that management, instead of spending all its time firefighting down here, is encouraged to go back upstream and identify the cause of problems initially while there's still time to react. Okay. The second example, just to understand how it works, is 2 projects, P17 and P3. The same resource has to work on the 2. That person will either work on this task, P17, where it's on the critical chain of that project, or work on P3, which is a non-critical task on that project. Okay. The answer is they should work on P17, right? Because that was on the critical chain of P17 and it was not on the critical chain of P3. We're measuring progress on the critical chain. So that resource could not help that resource move forward, that project move forward. Okay? It wasn't actually working on the critical chain, it's working on something else, right? So there's no point around it going there. It actually has to work on this one. Okay, so that's the notion of critical and non-critical. Be clear. So to summarize, this is the fever chart of portfolio management using the critical chain way. And I hope now at this stage, after you've seen the previous videos, maybe you can understand how it is possible to get to the stage where most of your projects are finishing on time. When I say most, what do we really mean? Normally, you're only going to have projects that go overdue for noble reasons, right? your projects are no longer going to be late because of managerial madness and incompetence. Okay, you're going to have taken, I don't know, a technological bet on a new technology, or you're going to bet on a partner who was meant to do something and he failed. Anyway, fairly noble reasons for a project to get late. Okay, and it won't be because your resource was working on the wrong subject at the wrong time, or you overloaded your system, or whatever. Okay, and that's, since managerial inefficiency is the main cause for projects being late, you're going to get very good due date performance. Okay, and the other thing which is hard to really understand, or rather hard to believe until you've done it, is the extraordinary change in the quality of life and the work environment. Right, we're going from a situation where you have people getting nervous breakdowns, working late nights, weekends, arguing all the time, lying to each other about dates and times and whatever. They're ashamed of the work they're doing because they're in such work environments they can't exploit all their training and experience, and they're not happy with the products they're designing. It's just a big mess, right? I mean, I work in all kinds of all departments of organizations, in production, in marketing, and whatever. And right now, very often, it's in the project environment, and in particular product development, where there's the most stress and it's the most unhealthy environment. Okay, and it's avoidable. You could actually be having your projects going twice as fast, doing twice as many, doing them half the time, finishing them on time with good visibility and a really good work environment. Okay, and instead of having something where 10, 20, 30% of people's time is spent in stupid meetings, trying to decide on which project to work or what to do, people would just have to look at the graph and say, okay, I have to work on that. You don't even have to go and ask your boss to know what project you should be working on. It's transparent, objective, and if everybody obeys the rules everywhere, you'll be finishing nearly all your projects very fast and on time. Okay, so that's the beauty of critical chain, and we see it through execution, but of course you have to prepare it. So you get the step change where you have twice as many projects, twice as fast, and nearly all on time, right? The next video, and the last, is on the process of ongoing improvement, on how you can go even further. I hope you watch it. Thank you.